All right, now let's go through some practice strips with our newly learned ventricular rhythms. So here's our first practice strip. So we're going to go through our 6 steps, even though it seems silly because it helps you make sure that you're not jumping to conclusions. Do we have regularity? No, I don't really see anything. Ventricular rate, maybe 10, maybe. You could potentially call this a QRS complex. Potentially. Atrial rate, I don't see any obvious P waves, so I'm going to put 0. What is my QRS duration? Well, it is definitely wide. Definitely wide. If I tried to measure that out, let's see, 5, 6, 7, maybe 8, 9, maybe 10 boxes. So maybe 0.40 seconds. Definitely wide. P waves, we don't have any. PR interval, don't have any. P to QRS ratio, more QRSs, technically, one more QRS. T waves, oh, maybe I was including that T wave there as part of the QRS, so this QRS is probably not quite that wide. Maybe it's about 0.20. The T wave we do have, it is there, but it is discordant. So it's going the opposite direction of your QRS complex. ST segment, I would just put unable to measure because it's really hard to see where the QRS ends and the T wave starts. Artifact, no, I don't think so. I think this is a clean EKG. So what I have is a mostly flat line. Mostly flat line. Here we go. Ooh. 1, 2. If I tried to draw a ruler straight through, it looks pretty flat. I can cover most of that with my little ruler. So this I would call asystole. If you wanted to be fancy, you could call it an agonal rhythm, with that being like the last ventricular depolarization before true asystole happens. But I would say the majority of this rhythm is asystole. I would just call this asystole. I would be treating it as asystole as well. All right, here's our second rhythm here. So regularity, does it look regular? No, I don't really see any symmetry. So I'm going to say not regular. I'm going to go with irregular. Irregular. What is my ventricular rate? So your question is really, do I have measurable QRS complexes? And I would say no, because that could be a QRS, that could be a QRS. This could be a QRS. I don't really know where the QRS complexes are. I do see like squiggles, but I don't see QRS complexes. So I'm going to go unable to obtain, and I definitely don't see P waves. So I cannot obtain an atrial rate either. Can't measure the QRS duration. Each one of those that I highlighted is different. No P waves, no PR interval, no P to QRS ratio. Oops. Interesting. All right. No T waves, no discernible ST segment. Any artifact? No, I don't think so. I don't think this is artifact. It is squiggles, so you could say, is it like asystole with artifact? No, I think there's enough squiggles, and if I really kind of zoom in and try to say, how big are these squiggles from the tallest to the smallest? So this one falls on this line right here, and this guy's up here. So we're about 2.5 boxes in terms of amplitude, 2.5 small boxes in terms of amplitude. And so that is going to be meeting the criteria for a fine VFib. If you just put VFib, that would be acceptable for me. You don't need to differentiate between fine and coarse, but this is a VFib, so not asystole. We have more than one box of amplitude, and it looks a lot more squiggly than this one before it here. All right, our next rhythm here, is it regular? So do we have regular R to R intervals? Let's measure, because now we can actually see R to R intervals. That's exciting. So that's one. Yep, that one lines up. That one lines up. That one lines up. That one lines up. So this is regular. Yes. Yes, we do have regularity. So what's our ventricular rate? 1, 2, 3, 4, 5, 6, 7, 80. Ventricular rate is 80. What is our QRS duration? So if I try to figure out how wide is the QRS, I would say it starts right about here and it ends right about there. So it looks about 4 boxes. So it is wide. It is just a little bit wider than expected. So 0.16 wide. I always like to highlight when I find something that's abnormal. Do I have P waves? So now it's easy for me to at least identify QRS. Do I have a P wave before it? No. Do I have a P wave after it? No. So I'm going to put no. I don't have P waves, which means I cannot measure a PR interval, which means I definitely have more QRSs than P waves because I have no P waves. So my atrial rate is 0. Do I have T waves? So now, right, here's my R complex. Do I have T waves after? Yes. Yes, I do. Right there is a nice T wave. I mean, nice in that I can at least identify it as a waveform, but it is discordant. So we have the T wave inverted because in this case we have an R wave that is positive. So we have T wave going the opposite direction of our QRS complex. Our ST segment also looks to be a little depressed. So if I were to try and draw a line from before the QRS to after, you can see that really that right there would be our ST segment. It is below that baseline. So you could put ST depression as well, but that's fairly anticipated, fairly expected when you have a ventricular origin to your rhythm. Do I have any artifact? No. This is a beautiful, clean EKG. There's no extra bumps or squiggles. The baseline is pretty flat, so it looks good. So when I look at what I have abnormal, right, I have a wide complex, a ventricular rate of 80, I have no P waves, and I have discordant T waves. So all of those things put together should tell you it is a ventricular rhythm. So now you're trying to ask yourself, which of my ventricular rhythms? Ventricular escape, aka idioventricular, accelerated idioventricular, or ventricular tachycardia. And to make that determination, you go back to your ventricular rate. So your ventricular rate here is 80, which is faster than you expect for your idioventricular rhythm, but slower than you expect for your ventricular tachycardia. So this is accelerated. Oops, stop typing. Accelerated idioventricular rhythm. There we go. All right, let's look at our next practice strip here. So is it regular? Do we have good R to R intervals? So I'm going to go from the peak of this R wave to the next R wave here. So that one is that size, about the same size, about the same size. So this is nice and regular. Yes, regular. What is our ventricular rate? It looks to be about 40. Remember, you can always use your rule of 300, or you can use, so it comes out slow, or you can use your R to R interval math to get a more accurate heart rate. But since we'll assume that it is a 6-second strip, we'll call it 40. What is my QRS duration? So if I'm measuring here, this one looks like it falls right on that dark line. And I would actually say this is my J point personally. I would probably end my measurement there. So it is about 4 lines. If you included up to here, I wouldn't fault you for it. It's hard to say which one is the J point. I personally think that is the J point. It just feels like the end to me. But either way, it's wide. 0.16 seconds. So that is abnormal. Do I have any P waves? Do I have any P waves before it? Nope. 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 And let's just do a quick scan of our whole baseline, looking for maybe P waves that are not connected. Is this a heart block rhythm? Because remember, a 3rd-degree heart block can have those weird extra P waves that are not particularly close. But no, I don't see any. No P waves. So cannot measure a PR interval, P to QRS ratio. We only have QRSs. We don't have Ps. Do I have a T wave? So right here, yes, I would say I do have T waves. T wave is right here. So this T wave is upright. I would still call it discordant because when you compare it to the QRS complex, this has a very large S wave. So really the majority of the QRS is negative, and the majority of your T wave is positive. So I would call it a discordant T wave. Do I have it in the ST segment, and is it elevated or depressed? So if I take my baseline and try to draw it through, I would say that this is ST elevation. This is ST elevation up here. Our baseline is way down here. Our ST segment is way up here. So that is significant. ST depression, we tend to expect ST elevation. We don't necessarily expect with our ventricular rhythm, so it is something to still note and make sure that you document so that you kind of trigger yourself to go get that 12 lead and rule out a STEMI. No artifact here. So our abnormalities is a wide complex rhythm, a slow ventricular rate with discordant T waves. So what do we call this? Oops, I'm on the wrong screen. There we go. What do we call this? This is going to be another ventricular rhythm. So this is going to be idioventricular rhythm. It meets the heart rate criteria. It is wide complex. So you could call that idioventricular. You could also call it a ventricular escape rhythm if you like that terminology better. They both mean the same thing. You should put with ST elevation on this one, just because ST elevation is always concerning, but we'll leave it. It's good enough. All right, last one here. Is it regular? Is it regular? Let's take a look. So here's my little R to R interval marker. I'm going to go from like the top of the peak, just because I feel like that might be the easiest to measure, to the next peak right here and see, moved my EKG, see if that marches out. So come on, I don't want the EKG. I want my little guy. There we go. Does it march out? And it does. It looks like they're all pretty equally spaced. So as I'm coming closer over here, they're still actually spacing-wise about the same, even though they look a little bit different. So I would go ahead and call this regular. I would say this is a regular rhythm. What is my ventricular rate? So I could count it. With this one, I probably would be more apt to use the rule of 300. So find one that falls kind of on a dark line. This one's good. So I'm going to move that over there and say the heart rate's right around 150 from peak to peak. So I would say the ventricular rate is about 150. You could count each one and multiply by 10 if you like that better. What is my QRS duration? So it's really hard for me to differentiate the QRS from the T waves here. I think on this waveform, yeah, it's quite difficult. I would say this is the start of one and the end of one right here. And I would probably call this little rounded part the T wave personally, but it's very hard. It's very hard to differentiate, but any way that you try to differentiate, you're going to come up with a wide QRS duration. So it looks like mine came out to about 0.20, the one that I measured, but it's wide. That is the takeaway. I don't see any obvious P waves. You can make an argument that maybe you've got some P waves trying to push through there, but we'll just say no for now and leave you guys to that in-depth search for P waves when you go into 12 lead. So unable to measure your PR interval, unable to determine a P to QRS ratio. They're not really related to each other, so there's definitely more QRSs. T wave, hard to find. I would probably just use unable to identify with this particular rhythm because it's really hard to see where it stops and starts. Same thing for your ST segment. I don't see any artifacts though. This is a nice clean rhythm. So what do I have that's abnormal? It's wide complex. We have a very fast ventricular rate, no P waves at all. So this is going to be a ventricular tachycardia. Now, can you be more specific and say, is this monomorphic or polymorphic VTach? And I would argue for this one, you can be more specific. So this is pretty clearly, there's multiple shapes, polymorphic, multiple shapes to these QRS complexes. They are not all exactly the same as one another. So we've got some that are taller, some that are shorter and wider. These ones over here are different. This one is taller than most of them. So I would call this a polymorphic VTach. Now, I would not call this a torsades de points because it's just not a long enough rhythm. I don't see any true twisting, any ribbon twisting, any tightening of this rhythm. So I would just call it a polymorphic VTach. And that's it for our practice strips. Hopefully you feel a little bit better at identifying those rhythms.